Hello everyone. In this question, we have two cyclists, Abhijit and Vani. They move in the opposite directions from a point on the circle at t is equal to 0. Abhijit has constant speed while Vani starts from rest and magnitude of her tangential acceleration is constant. Whenever this tangential acceleration has the constant magnitude, we can easily use the equations of kinematics, whether the particle moves on a straight line or moves on a circle or any curved path. Okay, keep in mind, whenever the magnitude of the tangential acceleration is constant, we can use the equations of kinematics. Now they meet again on the track at some time t, and when they meet they have the same speed. So question has given four options, and out of these four options only one is correct. We have to find the correct option. See, we'll start our solution from this information. They meet at time t, and when they meet they have the same speed. Question says Abhijit always has a constant speed. Let us consider this speed as v. The speed of Abhijit we consider as v. So since they are moving with the same speed, this is the speed of Abhijit v. Now we are going to find the speed of Vani at time t, and we can use the equations of kinematics. So Vani's initial speed is 0. She is starting from rest. So putting it 0 plus Vani's tangential acceleration has, let's say, the magnitude a, and we need to find her speed at time t. You get this expression? Abhijit has this speed v, and when you write Vani's speed at time t, you will write it as u plus acceleration into time. Her u is 0. She is starting from rest. The magnitude of tangential acceleration we are writing as a, which is constant, and then time t. Agree? So we get the idea that v is equal to at. Now, question was asking the distance traveled. Okay, let us check how much Abhijit has traveled. The distance traveled by Abhijit will be his speed v into the time interval t. Abhijit traveled the distance is equal to vt. Okay. Now, if we check the distance traveled by Vani, we can again use the equations of kinematics. This distance I will write as 0t plus half at square. Whenever the magnitude of the tangential acceleration is constant, we can use the equations of kinematics, whether the particle is moving on a circle or the particle is moving on any curved path or any straight line. Now, rearranging the terms, this becomes 0. So we are having half at into t. Agree? Now, this at can be written as what? We have seen that at can be written as v. So rewriting this expression, half this at is written as v, this at is written as v, and then here we are having vt. See the interesting thing. If Abhijit has traveled distance vt, then Vani has traveled the distance vt by 2. It means Abhijit has traveled twice the distance as compared to the distance traveled by the Vani. So which option should be correct? The first option must be correct. The diagram was like this. If you want the diagram, here was the circle, let's say, and then t is equal to 0. We consider this moment t is equal to 0. Let's say from here the Abhijit has to go in this direction and Vani has to go in the opposite direction. Now this Abhijit will travel twice the distance as compared to the Vani. You get this thing? And then they will meet again at some point of the circle at time t. When they were meeting, according to the given information, they had the same speed. So we obtained their speed, and from there onwards, we obtained the distance traveled by them, and we got the correct option. I hope you understood the solution. This question can easily be done by making the velocity versus time graph of Abhijit and Vani also. If you wish, you can give it a try. Stay awesome. See you again.